Hello and welcome to another video of Matoklasan. And in this video, I'm going to show you how to perform the Spearman rank correlation in MS Excel. The Spearman rank correlation is the non-parametric counterpart of the Pearson product moment or Pearson R. So if you want to correlate two variables but they are ordinal, or if you have two variables but they are not normally distributed, then you can use this test as an alternative. In our example, let us assume that two teachers were asked to rate 8 different textbooks for a specific subject. The lowest score is 0 and the highest score is 30 points. Now, points were assigned for each several criteria like content, illustrative examples, and readability of the textbook. For textbook A, teacher gave it 14 out of 30 and teacher 2 also gave it 14 out of 30. But textbook C, they have different scores for this one, 28 for teacher 1 and 30 for teacher 2. And now we want to know whether there's correlation between the teachers' ratings. And if yes, is the correlation coefficient significant? Now, for this one, our null hypothesis will be there's no correlation between the ratings of the teachers. And to start with the Spearman rank correlation, the first thing that we need to do is to transform these scores or ratings into ranks. And to do that, I'm going to use the rank function in Excel. In this case, I'm going to use the rank average so that if we would encounter equal ranks, Excel will get the average of these equal ranks. So the number here is 14 and the reference is from 14 to 19. Then comma, I'm going to use 0 for descending so that the highest point will be rank 1 and the lowest will be rank 8 possibly. So I'm going to type 0. Now for us to copy paste the formula easily, the reference should not change, so I'm going to put some $sign here in our reference so that if we will copy paste this formula in the remaining cells, this range will remain. Okay, so enter. So 14 here is rank 7. Dragging this, rank 1 is 30 and rank 2 is 28. So I think there are no tied ranks, right? So we can use the Spearman rank correlation coefficient. Okay, how about the other column? So here, rank average again, open parentheses, the reference is 14. Then the range is from 14 to 17. Also gonna place the $sign here. You can just press F4 on your keyboard, but I'm having trouble in my keypad, that's why I can't use the F4. So 0 here again for ascending. Enter. Okay, so rank 1 here is 28, or rather 30, and then rank 2 is 26, rank 3 is 24. So I think we got the correct rankings. And here, as you can see, we don't have tied ranks, so it's really ideal for us to use the Spearman rank correlation coefficient. Now that we have the ranks, we can now get the correlation coefficient or the Spearman raw coefficient. Just need to type equal sign, then correl for correlation, open parentheses. The first array of data is from 7 to 5, comma, then the second array of data from 8 to 6, close parentheses, and the correlation coefficient rounded to 4 decimal places is 0.6429. We actually have an alternative if you forgot the correlation but you remember the formula for Pearson, which is this one, Pearson, then same array, yes, so we have the same coefficient. This is possible because the Spearman raw is actually also using the pattern for the formula of Pearson R, but we use rankings instead of the actual observed data. Now that we have our coefficient, which is positive 0.64, we can say that there is a strong positive correlation between the two ratings. Now, what if we want to check the significance of this coefficient, 0.64? We're going to need the T-Statistic formula, which is R sub S, which just the correlation coefficient, times the square root of n minus 2 all over square root of 1 minus R sub S squared. So to do that, we're going to need the following values. First, the pairwise or case n, just the number of cases. Okay, so here we have 1, 2, 3, 4, 5, 6, 7, and 8. So you can just type 8 here. But if you happen to have a big set of data, you can use the count function in Excel. So just use count, open parenthesis, then select this set of data, enter, and you have 8 here. Now, using this formula of test statistic, we have equal sign, open parenthesis to refer to the numerator here. So we need the R sub S. In this case, just to be sure, I'm going to use absolute value function because there's a possibility that the raw coefficient is negative, right? Because there could be a negative correlation. But since in the statistic, we're going to use the p-value method, we need the positive value for this one. You can use the absolute value function right away, or if the coefficient is positive, no need to write this one. But just to be sure, I'm going to add the absolute value for the coefficient. This is R sub S, so I'm going to select this sheet. Okay, multiplied to the square root, that's SQRT, of n minus 2. So n here is 8. Select that sheet, then minus 2. It's actually cell, not sheet. Okay. All right. So square root of C17 minus 2. So we're done with the numerator. I'm going to close it now. Divided by, open parenthesis, the square root of this whole term. So I'm going to type square root, open parenthesis, 1 minus. All right. So the R sub S again, but this time I'm going to make it squared. So you have there the caret symbol, squared for squared. Then close it with the parenthesis. Enter. And we have now the T-Statistic 2.0557. Are we done? Not yet, because we still need to get the p-value for us to decide if the correlation coefficient is significant or not. So with that, going to get the degrees of freedom. 8 minus 2, that's just n minus 2. So 8 minus 2. The degrees of freedom is 6. The p-value is equal to t-dist, this one, open parenthesis. For the value of x, I'm going to choose the t-statistic. So that's the reason why we solve for this one first. Comma, the degrees of freedom is 6. And then comma. Here, we need to select the two-tailed distribution. Okay, so close parenthesis, equal sign, and the p-value now is 0.0856. Now, in this case, the level of significance is not stated, so we'll just assume that it's 0.05. And as we all know, since the p-value is greater than the level of significance or alpha level 0.05, do not reject the null hypothesis. So what does it mean? It means that the correlation coefficient for this one, which is 0.64, is not significant. So what does it mean? Significant. So what does this mean? Okay, it means that the correlation coefficient cannot be used to other samples in the population. So if we got this correlation coefficient, which is a strong positive correlation between the two teachers, there's no assurance that if we'll get another sample or another set of teachers which will evaluate the same textbook, there's no assurance that we'll get the same coefficient, or which is a strong positive correlation coefficient. Now, Does this discredit this value? No, it depends. So if in your study you just need to know the consistency between the evaluation of the two teachers, then you can use this correlation coefficient result. But if you want to infer to the population or to other sample size, then it cannot be, because the result is not significant. Now, if you're not contented with the p-value approach and you want to use the traditional method or the critical value method, you can actually use another function in Excel so that you could see the critical value at t. So here we're going to use equal sign t dot inv for inverse dot 2t. So this one. And then probability refers to the level of significance, which is 0.05, and the degrees of freedom, of course, here is 6. So by doing that, we'll get the value of 2.4469. So this is the critical value. So if we're going to compare it to the t-statistic, which is 2.05, the t-statistic is less than the critical value. So again, the decision is do not reject, or the coefficient still is not significant. So we have the same decision for the p-value approach and critical value approach. And if you happen to encounter tied ranks or equal rankings during the transformation of the data, then you can use the Kendall-Stowe as an alternative. Check it in the description down below. See you in the next video.